Hello friends, welcome back to our channel. So today we'll see one more concept in algorithms, that is a disjoint sets. Disjoint sets. So we know that a set is a collection of elements, right? So a set is a collection of elements. Collection of elements. So then what we call it as a disjoint sets. So if you consider any two sets, right? Let it be S1 and S2. So these two sets are having a different elements like 1, 2, 3, and here it is 4, 5, and 6. And when we say that S1 and S2 are a disjoint sets, so when the S1 intersection S2, that means the common element, right? So is equal to 5. That means there is no common element in both the sets, right? There is no common element. Then we can say these two sets are disjoint sets. That means no common element. So we usually, the intersection means we need to get the common element in both the sets, right? So there is no common element in S1 and S2. Then S1 and S2 called as disjoint sets. Disjoint sets. So there should not be any common element in both the sets. Right? Now, what are the operations that can be done on these disjoint sets? So the operations that can be performed is the first one, simple union, simple find. That means we know that union means combining both the sets. So we will combine both the sets and we'll get a new set with all the elements of both the sets, S1 and S2. So that is the union, simple union. That is a simple union. So there is no constraint, right? And next is simple find. So we need to find the parent of that particular element. So why we are calling it as a parent means any set can be represented in terms of a tree data structure. Okay, a set is represented as a tree data structure. So as we are calling it as tree, definitely there will be a root node. Okay, and usually we can call this as a parent node. Root node or a parent node. For example, let us take 1, 2 and 3. We can say 1 is a root node or 1 will be the parent of 2 and 3. Okay, so that's why we can call it as a parent node or a root node. So simple find means we need to find whether the element is available in the set or not, and if yes, we will return the parent node, the parent of that particular element. And the next one, weighted union. Weighted union. So there will be some sort of weightages, and based upon that weights we have to perform the union operation. And the fourth one, collapsing find. Collapsing find, which is a slight different from a simple find, which is a slight difference from the simple find. And in this session, we will focus on simple union and simple find. So how can we perform this simple union between the two different sets, and how can we perform the simple find operation? So one thing, we are working on the disjoint sets. Disjoint sets means we need to take a more than one set, and there should not be any common element in both the sets. For example, S1 and S2. So let us consider S1 is having some A, B, C, and S2 is having some E, F, G. So these two are called as a disjoint set because there is no common element. For example, if this is having one more element like 3, 4, 5, 6. We can't say S1 and S2 are the disjoint, because here S1 and S1 intersection S2 is having one element called 3. So if there is any common element, we can't say those sets as a disjoint set. If the intersection is 5, that means no element, then only we can say these two are the disjoint sets. Now it will be the disjoint sets. So 1, 2, 3 in one set, 4, 5, 6 in another set. Right? So hope you understood this one. Now we'll see the simple union and simple find. First, a simple union. Let us consider the simple union. So simple union means we are supposed to apply the union operation between the elements. So simple union. So first what we have to do, we have to consider all the elements as a individual elements, right? So consider all elements as individual. So usually we will represent this one with a tree data structure. So tree data structure, right? So obviously there will be a root node or parent, right? So consider P of I is the parent of node I. So usually the P of I is represented as a parent of node I. Okay, if you consider any node, P of I will be represented as a parent. And see, initialize P of I is equal to -1 for root nodes. If the node is a root node, the parent will be -1. Okay, if it is a root node. So obviously, if it is a root node, there will be no parent, right? So that will be the first node, right? So we have to initialize to -1 for such root nodes. And fourth, so we have to collaborate, or we have to perform the union operation with one by one. Okay, perform simple union for every element. And finally, update the parent after union operation. Right? So these are the steps we need to follow, right? The first one, consider all the elements as a single elements, individual elements. Next, let us represent the P of I is the parent or node, a parent of node I, and then initialize the parent -1 for the as a parent. I mean -1 for the parent nodes. That means a root node, and then perform the simple union for every element one by one. Okay. Then update the PI after union operation. See, for example, if you apply the union operation, so the -1 should be only for the root node. So only one node should have the -1, right? So remember all these points. Now we'll move on with the example so that you can understand that one. Simple union. See, let us take the elements. The elements as 1, 2, 3, 4, 5 and 6. These are all the different elements. So now what we have to do? So we have to consider the tree structure. 1, 2, 3, 4, 5, 6. So this is a tree. Now we have to find out the table of all the parents. So I'll write here. I'll write here. So 1, 2, 3, 4, 5, 6. This is a I value. This is a parent of I value. So this is the parent of I value. What happens? Now what we have to do, initialize -1 to the parent. Initialize -1 to the parent. So here all these are the individual elements. So these are all the roots. Okay. So this is one tree with only one element. So what is the value of parent of this one? It will be -1 because it is a root. Parent of 2, again it's -1 because it's a single element. And it is also -1, -1, -1 and -1. Okay. Initially this is a -1. Initially this is a -1. What happens? Now perform the union operation between 1 and 2, union operation between 3 and 4, union operation between 5 and 6. Okay. Now you can take 1 as a root and 2 as a child, 3 as a root, 4 as a child, 5 as a root, 6 as a child. So that means we are joining, we are performing the union operations in between 1 and 2, 3 and 4, 5 and 6. We are combining the elements, right? Now update the value, update the parent of nodes. So what is the parent of 1? Here 1 is a root node. So parent of 1 is -1 only. What is the parent of 2? Parent of 2 is 1. Parent of 2 is 1. So it will be -1, it will be 1. And parent of 3, -1. Parent of 4, it's a 3. Parent of 5, it's a -1 because this is a root. 6, it's 5. See, after combining these one, we got the values in this manner. Okay. So after completion of the union operation between 1, 2, 3, 4, 5, 6. Now what we have to do? You have to perform the union between these two things. So union of, okay, 1, 3. So what happens here? So 1 with a 2 and take one more child which is 3, which is having 4. So this is a union of 1, 3. Here 1 is a root node, 3 is a root node. 1 is a root node, 3 is a root node. So we are combining these two things. Okay. So now what happens? 1 becomes the root node. 1 becomes the root node. So update the parents. So the parent of 1 is a -1 because it's a root. Parent of 2, it's a 1. Parent of 3, again it's 1. Parent of 4, it's a 3. Okay. And similarly, this is a -1 and 5. -1 and 5. You can observe again, we are having two -1s. But if you perform the union operation, what we have done, so only one root should be there. So again we have to combine union 1 and 5 and 6. See, union of 1 and 5. So 1 is this one. So 1 which gives with a 2, another child with a 3 which is having a child 4, and now 5 and 6. One more child you can give, it's a 5, and it can give it as a 6 as a child. Now what happens? Again update the parent table, which is root of 1, it is a -1. Root of parent of 2, it is 1. Parent of 3, it is 1. Parent of 4, it is 3. Parent of 5, it is 1. Parent of 6, it is 5. Right? Now you can observe there is only one -1 here. That means only one root. So this is a root. So after joining all these things, after performing the union operation of all these elements, we got this particular tree, which is having only one root followed by different children. So for this, the algorithm will be simple, which is a union of I comma j, which gives the parent of j is equal to I. That's it. So this is a simple algorithm to perform the union. So one by one, we have to join the elements. We have to combine the elements. That's called as a union. And the resultant for after every joining, after every union operation, we have to update the parent table. We have to update the parent table, right? So this is how we can perform this simple union. So initially all these are the individual elements, so individual trees, only one root node is there. So gradually we are combining one node with another node, one set with another set. Okay, and we are updating the parent table. For every node we are giving the parent. So P of I represents the parent. So this is a simple algorithm for simple union. Now what we have to do, we have to perform the simple find. We have to find the element. So our next operation is simple find. So I'll erase all these things. I will erase all these things. See the final one is this one 1, 2, 3, 5, 4 and 6. So the same thing here. Okay, the same thing here. I am erasing this one also. So what we have to do? We have to find the element from this particular table, right? So see, the algorithm for this one is find of I. We need to find I, and we have to repeat the steps while the parent of I is greater than 0. Simply what we have to do, so we have to initialize this parent of I to I and close, and finally you can return the I value. So this is a simple algorithm for find. See, you can check. First, if you want to find a 4, okay, so what is the parent of 4? What is the parent of 4? The parent of 4 is 3. 3, okay, which is not a minus 1. We know that the parent of root node is minus 1. We know that the parent of root node is minus 1. So we need to repeat this process. We need to find every element parent until it reaches to minus 1. So that's why we have written this one. So we have to repeat the process until the parent node is greater than 0. So if the parent is greater than 0, that implies there is another level of parent, right? See, for example, if you want to find the 4, the parent of 4 is equal to 3, which is greater than 0. What we have to do? So I is equal to parent of 4. So that is equal to 3. Now I is equal to 3. I is equal to 3. Now perform the same operation here. I is equal to 3. So parent of 3 is equal to, what is the parent of 3? It is 1. So parent of 3, you can see here. Parent of 3 it is 1. 1, which is also greater than 0. So simply initialize the parent of 3 to I, which is equal to 1. Now I becomes 1, and see P of 1 is equal to, what's the parent of 1? What's the parent of 1? It's a minus 1 because it's a root node, right? So it is a minus 1. So which is less than 0. Which is less than 0. So simply what we have to do, so you have to return I. Return I means it's a 1. So 1 is a root node. 1 is a root node. So if you got that root node, that implies the value is available in our union. Okay, in our set of elements. So this particular find will return a root element. It will return the root element. So this is the simple logic for applying the find operation. So we need to keep on moving until the P of I, the parent of I, is less than 0. If it is greater than 0, simply we have to repeat this process. Okay, so whenever it becomes less than 0, immediately we can say that the root is I. The root is I. So this is a simple find operation. So simple union and simple find. Okay, so hope you understood this. These two operations are in disjoint sets. So once again, the disjoint sets, when we call it as a disjoint sets, means if the intersection of both the sets are 0, that means there is no common element in between two different sets, we call it as a disjoint sets, and we can perform a few operations on the disjoint sets. That is a simple find, simple union, and weighted union, and collapsing find. So in this session we have seen the simple union and simple find algorithms, and how we can find out the root of the element and how we can perform the union of all the elements. So one thing we have to remember, we have to represent any node in this disjoint sets as a roots, as a tree structure. So we are using the tree data structure to represent the set. Right? So I'll stop here and hope you enjoyed the session. And if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.